Hello, Professor Afandi. You can start the presentation right now.
Oh, sorry, getting some problem.
Okay.
Yeah, I
You can
will
start
try
now.
again. Yeah. Okay. I want to make a share about deliver for this material. It is should be given in English, Indonesia, or combine both, because the participants the most are in Indonesia or Indonesian.
In English, Professor, because we have some participants from India, I think, from India and other countries.
Yeah, okay, thank you very much. I will deliver my topic today. Thank you for briefly introduction about me. I think it is important to us to discuss about today, especially on my view. I will deliver my title in thunderstorm algorithm in optimal scheduling. How about this algorithm? I want to share more about this is my outline for the whole of my presentation. Maybe the first is breaking an introduction. After that, followed by thunderstorm algorithm, also power system, dynamic operation, and application to economic dispatch or dynamic dispatch. I think this is important time for me because maybe somebody know me, but also thanks to the Mr. Freitas, I think he has contacted me also to give this chance and belongs to the UEE. Thank you very much, Mr. Freitas.
Terima kasih. Thank you, Prof. Afandi.
Yeah, so we are going to the one scene together in this meeting. Also, we will discuss. I don't know, many people join this meeting. I hope we can share or we can discuss more and improve our cooperation later. This is technically, if I remind to Jogja, perhaps it will take 6 hours. But it's maybe sometimes takes 7 hours. But just click by Zoom. We are together on the virtual meeting. Thank you very much for the chance here. I don't know. I have visited the UEE maybe in 2019. 2 years ago. I don't know electrical. I think stay in this campus already there. Yeah, but I don't know for the first with Mr. Pedro stay here now. Thank you very much. Next one, I want to introduce the PES chapter in Indonesia, or Power and Energy Society chapter. This is the current condition in 2021 during the COVID-19 pandemic. The IEEE PES chapter was established in 2015, approved by US, especially in PES. So now we have almost actively members, 83. It means actively they have renewed for the member ID, but we have more than 100. So please come and join with us together, develop our expertise and make some activity on join research on other activities. But from the members, we can find many expertises belong to them. But the major is from power, energy, industry application. So in this chapter, we have majority in power and energy system at the title of the chapter. I will introduce briefly for my department, also in my faculty. We are organized 24 study program in our faculty, but electric department or EET has 7 departments where I am stay there, especially for the electrical engineering. We serve in diploma and graduate and master degree or postgraduate. Now still preparing for opening the doctoral Dr. Program through the proposal. This is our research office. We have the web for the current research office, which supported by many lecturers and many industrial to join some research with me based on my expertise on the power and energy system related their enterprise also, and then they also do many research at their own office. This is this is the main office for this work in my campus where I stay there. Well, this is currently thing. So please, please going down to my office if you are coming to the Malang or Surabaya. It's closer, almost 1 hour. This is the whole of my research core, especially belong to the power system, which use related field such as energy system, power electronic, materials, control system, information technology, also power energy. Another one. We also make a close with many current issues related energy system like harvesting, embedded system, also efficiency improvement, automation belong to the such robotic. Also we expand to the remote control or remote area, and then transaction not only in energy, also in economic aspect. Like now we will discuss about them. Before come to my title, thunderstorm algorithm and economic dispatch, I want to introduce the first part is belong to the thunderstorm algorithm. This is the cloud chart in nature, especially characteristic and behavior. Cloud consists of the charge, positive charge and negative charge. As we know that it can be generated some lightning. So there will transfer and discharge all the particles from the sky to the earth, as we know as the thunderstorm algorithm, shortly or singly in lightning. After that, they will go to the ground through the streamer, especially like that. So until it discharge all the electrical charge in the sky. This is a mechanism in nature. After that, I want to open up our knowledge about striking type in nature. I think this is a commonly information in our field, especially electrical engineering. Maybe through the high voltage, there are many terms related to the striking. So we know in nature it will be happen on the cloth to cloth or inside the cloth. After that, also cloth to the earth. This is the 3 types of the lightning in nature, cloth to cloth, and inside the cloth also being the lightning between cloth and cloth. After that, also cloth in nature. This is very important to introduce firstly for the thunderstorm algorithm, because the thunderstorm algorithm has inspired by the natural activity and behavior of the thunderstorm through the lightning as the single striking. After that, they will multiple lightning, so become a thunderstorm. This is a step or mechanism in nature belong to the three categories. The first is single. Singles mean one striking from the sky to the earth. They has several steps. The first is generating or generation of the lightning. After that, they followed by leader formation. So the final is discharge channel. After that, if we have more than one, so we call it the multiple lightning striking. It means the lightning more than one, so we call this is multiple. After that, if many, so we call the thunderstorm behavior or thunderstorm lightning. So from the 3 figure or the 3 mechanisms, also they has 3 steps. as the single, they has generation of the lighting, after that leader formation, and the third is discharge channel. If they being the multiple lighting, so they have a 3-step: charge separation, leader formation, and discharge channel. It means that the final also discharge. If they are become a thunderstorm, they also have a 3-step: electrical storm. Maybe this is the maybe some move of the electrical storm from the lightning. After that, lightning stop. After that, thunder shower. It's mean very multiple lightning. So 3 type in nature is very important to know how it will transfer to the thunderstorm algorithm. Now, this is, I think this is material who has stay on the inside of the cloud and thunderstorm process, like air unstable and mostile also. So in this case, I want to make some conclusion about the thunderstorm, especially in developing state, they matter state, and dissipating. So it means this is very important at the final is dissipating state, because all of the discharge from the sky will decreasing the cloud size of the charge. So it means it's very important during the thunderstorm in nature. How now, if we think about previous research, how to mix, how to know about characteristic and process of thunderstorm, we always still remember about the experiment of the Benjamin Franklin. You said kite, they fly from the ground to the sky until it's struck by lightning, and then the wire will be used to transfer electrical to the earth. This is simple and famous in our exercise about the Benjamin Franklin assessment about the lightning. Now we move to the inspiration about thunderstorm algorithm. This is only story of the thunderstorm algorithm where it was invented by some event in the sky around my house, especially in my parents, in January 13, 2016. The first I have idea and I have some opinion on some research about this is. So after that, I exercise many type of the thunderstorm before introducing thunderstorm algorithm. So it means that from the January 13, I look for and I search about the thunderstorm behavior and process in nature. Not only depend on electrical engineering, I also naturally from the many discussion with friend or another researcher how in nature and how should be transferred in mathematically. So I have discussed many set of the expertise in this development during thunderstorm. This is the figure that so I used to develop thunderstorm algorithm based on the natural mechanism. The first step I have to learn mechanism of thunderstorm algorithm. After that, I have to also auto-think innovation, which one it should be take from the innovation. After that, a computation model should be developed for express the natural process and mechanism. In simple, so at the natural moment, so I think how the natural moment it can be inspired in this algorithm. After that, I have discussed with many mathematicians, especially for support how make a model in mathematical expression. So after this discussion, I should decide and mix a model from the mathematical. After that, completely with all of the designed model in mathematical, I have read like a structure in how the thunderstorm algorithm should be matched with natural mechanism. So I have make a structure for it after that. So it is important to make some structure like that before it can be used and applied to the mathematical model and other transfer to the computer or the computering approach or computational approach. So it's mean very important to make or to create a hierarchical process in the thunderstorm algorithm. Now, next one is this is the cloud development of thunderstorm algorithm. How to express the cloud in nature and adapt to our behavior in this computational method. So I approach three type of the cloud from from the right, forward mechanism, expanded mechanism, and reverse mechanism. This is how I imitate the cloud in nature belong to the computation. The first is forward mechanism, and the third expand, and then the final is reverse. So in this case, we have three types of the cloud. Now, this is, I think this is only state for the thunderstorm algorithm comparing with natural activity or natural process. At the first point, we know that as previous slide, we call that lightning also has a three-step generation of the lightning, after that the leader formation, after that the discharge channel. So it become a multiple. So this thunderstorm in nature also have three steps. So the first is developing state, after that the mature state, after that dissipating state. So in this algorithm, also I put all the process in three phase as the natural mechanism has a three state. So I have in this algorithm we put on the three phase. The first phase is cloud. How make a cloud, how three cloud condition like a previous story in the nature. After that, the phase is streamer phase. The third is avalanche phase. Depend on the name, but in the process, is very similar. Next one is, this is in detail of the principle for the thunderstorm algorithm. The cloud phase and streamer phase and avalanche phase depend on the internal process and internal interaction. Like in the cloud phase, they have three steps: create the cloud, evaluate the cloud, and define the pilot leader. This is inside the process in the cloud phase. How the streamer phase has a four process in the algorithm. Select the prior streamer and then produce the tracking direction, and then the third is evaluate the path, and then the final is define the streaming track. How about the avalanche phase? Avalanche phase at the final for the process. This phase has two steps: evaluate the channel, and then after that replacing the streaming stack. So in this case, three phase in the thunderstorm algorithm depend on the internal or internal process of the phase. Next one is this. I think this is the how we can apply or we can put on the problem to solve, especially like that, or we transfer to the computation through the some programming on that another one from the cloud phase, streamer phase, and avalanche phase. At the illustration below, this is I categorize for the program with a main program, adjective program, and then thunderstorm algorithm program. So evaluate program and output program. I think it depends on us, depend on you also. If you apply this program and familiar with type of design the program using some tool, I don't know, maybe depend on each other. like a MATLAB or another tool, so we can divide many subprograms to avoid the heavy run in the computer on laptop. So we can put on the subprogram until it can be easier to transfer in the result. This is the history for the thunderstorm algorithm with all the ladder type. So the first promotion, especially in thunderstorm algorithm, we put on here, we glue on the 2016. This algorithm is promoting early at the PPIC Kumamoto on March 17. I think this is in bulletin for PPIC. So after that, in nationally, I promoted. I have promoted algorithm through the Majalah Komunikasi on 25 February, also 2016. After that, in Suara Pendidikan on 22 June 2018. So 6 years ago, I have promoted for the thunderstorm algorithm, but now we discuss more about this application. This is I want to briefly about the power system before talk the application of thunderstorm. I think it is familiar for us, the power system shortly in generation. And then after that, transmission, distribution, and demand at the final energy user. So in this case, if we call in the power producer, we have a producing of the energy. After that, the energy will be transmitting and distributing to the load as the energy user to use with many appliances or many type of the load. So in this case, the important thing is we should be no behavior or characteristic for 24 hours behavior consumption or production of the power or energy. Also, we have to know about the characteristic and behavior hourly. Maybe hourly during 24 hours for 7 days. So it's important to know about the behavior between the production and between the user. This is very important to know about dynamically the power consumption and power production. Well, then one is, this is only chart for the power consumption, especially in the generating side. It is important to make a certain combine between all of the power plant, which is suitable for producing energy at the certain time, especially or hourly time like that. Maybe depend on mandate, so we can put how it can be combined in economically to produce the energy. After that, we also consider the various loads. Various loads is mean load has a different characteristic with power producer, because load has a right to switch off and switch on of the own energy consumption. So it is very important to know during the existing transmitting and distributing the power and energy from the generating side to the load side. It is important to know each powerful during the operation. How about 24-hour operation? I think 24 hours and 7 days. It is very important to know and to mix power good between all of the type generating unit should be combined in a good and economically aspect. So it's mean demand forecasting is very important to know and makes how the power generating will be will be produced to meet demand at the various hours. This is very important. So we have to make some prediction about the demand, not only on short term, but maybe at mid-term and then long term is very important also, because if we know this person for the prediction of the power, we also predict the power production from the generator unit. So we also mix some combination in economically until it can be decided this is the unit commitment with economically aspect through the maybe through the technical requirement or some other requirement. It is important to know before we schedule for the 24 hours in 7 days. I think this is only possibility market if we think that the power system not only operated by single operator. We think in this figure we have three competitor in the market. So it means the enterprise only organize all of the power plant, but the power plant split from the transmission and distribution. This is a different operator for the transmission line and distribution line. Also, in the demand as the customer or energy user, it mean also depend on own capability in power purchasing. So it means if we think economically, so the power plant has rate on. After that, the operator also will charge if energy through the own transmission system and distribution system. So it means the load or user or power demand has comparing to the buy energy from which one or where the transmission and distribution can be flow their energy buy and sell. So it's been very important. So in this market, I think the power system not only operated by one single. So it means maybe it own operated in the system. So in this case, I mean in the dynamic dispatch, we also think that the power production is mean depend on only enterprise for the generating unit. After that, if the power source or flow in the transmission and distribution, so it means they pass by another operator. So it means the operator will charge for the power source on the transmission line and distribution line. So finally, customer or consumer will price from the generating unit and then transmission system and distribution in two of the operator. The first is energy rate from the power production. After that, energy is charged from the power flowing in the power line. So it's been very important to think the market only think that this is very important to make some bargaining of the buy and sell of the customer. Sorry. So if we think that the financial opportunity between two, we think that the different two is mean power generating and customer also an energy user. We have two possibility. The first, they will negotiate charge between enterprise and transmission operator or distribution operator. After that, the two channel also between an energy enterprise and energy user. So they will bargaining until it gets some reasonable price. After that, maybe energy user and transmission and distribution operator, they will also make some negotiate charge because they will buy some energy that through on the transmission line and distribution line, which is it being flows from the operation. This is very important to think about the rationality of the price. So if we think about price and charge can be negotiated between energy from the power production, and then after that customer as the energy user, and then operator as the infrastructure for transmission and distribution system operator. So maybe bargaining will be make some some suitable and economical decision between customer and enterprise, maybe customer and operator, maybe enterprise also with operator. So it's mean the bargaining price and charge is very important to think about the possibility how the customer will buy energy from where, like that. So customer also think the energy which buy they will flow from where. If we think then the operator and enterprise and customer is have a different right for the price and charge. How about the next one? This is the operating condition. I think this is commonly for us about the power system and how it will be operated in some criteria or some limited operation under technical or under environment. I think this is very important to us about the power system. It can be operated based on economic operation, but we also think that the system already existing for 24 hours. So during the 24 hours for 70, for 7 days, so it means all of the system should be continue for production and continue for consumption in the final of energy usage. So this is very important thing, how make a combination of the power production between all of the potential generating unit, which one and which will be operating together to support the system during the hourly or during some limited time. Now, this is the power sharing. Maybe the demand and energy, we can think about the demand, power plant, energy transition, and operating conditions. So I think it is very important to us, and we know that the power demand also increase hourly or decreasing at the night. So we know they are still in like a base load, maybe like average load, maybe like peaking load. This is very important to know about the demand always gradually from the 0 time until 24-hour operation. After that, how the power plant should be follow this characteristic. So it's mean very important because the power plant will be combined with many types, not only water, not only gas or steam, or another one. So it can be applied together, but in what the best combination should be thick to support the power demand in hourly on some certain time. After that, we also put the energy transaction because the power should be measured in financial aspect. So in this point, the cost for the power demand and power plant it is very important to know. After that, how the operating condition during this existing for the transfer and distributing the power system from the power plant to the demand. So the criteria requirement and another limitation for the operating condition is very important to apply at the time. So it means during 20 hours and 7 days, it is important to apply together. So it means we have to know how the demand characteristic and behavior. Also, we should be make how the power plant together and join for the existing system. This is integrated resource. This has so many possibility for integration in the system during the power delivery and power production in the generating unit. And then after that, at the final for energy using. So the first is maybe energy transaction periodically change. Maybe the operator will put on the price depend on limited time, like price on the day depend on the night. I think maybe this is a possibility for the change. So in this case, the operator make a periodically change in the rate, in the charge, in the system. So how about the operating condition? Operating condition also periodically change. The situation between night and day is very different. Rain and dry is very different. So it means the energy it depends on the flow. The system also operating with under certain situation, certain condition. How about now demand? Low demand, it means we have to know the hourly change. maybe gradually, maybe we still on the peak load, base load on average load is very important because the characteristic of demand is very different between like industrial, like house, or another type. After that, the power plant also followed for our leaching because the power plant should be many. Maybe I think the power plant should be combined with many type until it can be decide until this production of the power will be in cheaper. In cheaper is mean cheaper for production and cheaper cheaper for the energy user. So it's mean make some bargaining for the buy and sell of energy. This is the concept of dynamic economic dispatch because we will take 24 hours. So it's been load a very chain and then generating units also change. So we have to think about the dynamic economic dispatch, not only economic dispatch, but we should be saying it will be flow, it will be produced dynamically, and it will be used dynamically in the final energy consumption. So this is only stake how we can use like dynamic and economic dispatch based on the economic operation. After that, we also consider the operating condition, not only operating, but we also include the environment protection system. It means how to control the discharge for the pollutant and emission to the air. This is depend on us. We can include here or not, but we have to think about the possibility combination to the all of the system, which it can be operating existingly with all condition and possibility. This is a dominant penalty factor, which I promise to the computation on also depend on the emission standard. And emission standard is mean we take some standard from the environment. We will put on the standard for the emission level. After that, we also consider during the fossil fuel base for generator, we will produce in emission. So we control with we will control using the emission standard from the another aspect of the power production. So after that, we will also consider the allowance of the totally emission production until it become combination, and then we can use in terminal penalty factor. I think this is a new approach for the penalty factor. As you know, the penalty factor depend on the power, maximum power, and currently power production. Now in this approach for dynamic penalty factor or dominant penalty factor based on include with emission standard. This is a model this is model that I use for the power system testing during the application of the thunderstorm algorithm. I use for IEEE with a model for 30 bus system like this diagram shows the combination between many generator and the structure for the power system. So in this case, we applied for the system, which is requirement like this. This is only limitation for the voltage graduation, especially up and down. And then we use also compromise factor in 0.5. After that, we put on the limitation for the power transfer capability in 90%. Power loss with 10%, and then this is include to 0.85 kilogram per megawatt. This is including for the environment protection during the operation in the power system. Another one is parameter for thunderstorm. We use 1 of the avalanche, 50 of the charge, and then 100 of the streamer for the other factor. This is only This is only data provided by IEEE, and then this hourly design for the load demand that I use for the model in this application of thunderstorm algorithm. Like now, this is the profile of the cloud, initial cloud in the thunderstorm algorithm. In this figure, I use E-type of the cloud, especially forward mechanism. So the cloud will move from the small size going to up. So it means forward mechanism. So in this figure, I use for E-type, move from the small to the up and bigger and bigger. Next one, this is the computational speed of the thunderstorm algorithm, depend on the cloud charge size from the 25 until 100 of the charge inside of the cloud in the computation. This is a profile or characteristic speed for the computational. Next one, this is the striking direction as in nature. At the left set, this is illustration for in nature. The bright white, this is the successful of the striking. And then in this computation, we use a 4 for success factor. So each striking has a 4 direction. So it means the first strike have a 4 direction, 1, 2, 3, and 4. And the second striking also has a 4 stroke, 1, 2, 3, 4. Other than the third also have 4, 1, 2, 3, 4, until the final in this figure check 4, 1, 2, 3, 4. But directly for the red line, this is the successful, like in nature, brightly white. This is brightly for the nature structure, but this is for successful or the best solution during the computation using thunderstorm algorithm. I think this is the speed in calculation of the iteration. So this just maybe this just shows for the streaming flow during 20 hours operation until like this from start 1 hour and then 20 hour with optimal solution remain at the iteration. So this is each iteration hourly. I think this is overrate emission coefficient that related to the how the level offer level of the standard during the emission protection like that. I think I have discussed previous. Next one is penalty factor performance. As I said before, the terminal penalty factor depend on the various power production during hourly, and then it also depend on the characteristic in the maximum power during combination between all of the generating unit, which it can be applied together to support the power production during certain load. Certain load in the computation. So this is a power code for the hourly during 24 hours with 6 generating unit, many type, but one is generator one used at the swing pass, so it will produce in higher and higher. Next one, this is as I said before, production for the emission higher than the limitation. So it means financially this is should be compensated using some cost in the operation. So green line is mean the emission should be compensated with certain costs in the operation. So totally it will like this. So we have the full cost depend on the full base, and then after that we also consider emission cost dynamically during 24 hours for 7 days. So it means all combination between cost, generating operation and environment protection. I think this is detail for the numerical result depend on the power load and power generation, and then it compute to 24 hours. Okay, I think this is the final set my presentation. I saw many paper published in journal and presentation like that. So you can explore more if you have interested in that soal algorithm, and we open to apply together in your case or another case approach for the thunderstorm application. I think like that. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Afandi, for your precise presentation. So for audience, I would like to just remind you that we received a question in the question and answer session. So anyone who wants to ask question, please put in the chat box, which is posted by the committee in the chat. So the question here will be put on the slide 2, and it will be discussed during the discussion or question and answer session after the second presenter. So let us move to the next presenter, to the second presenter, which is Dr. Muhammad Pani Sulaima. Dr. Pani?
Yeah.
Okay.
Kalau duit pas kuliah itu ada office ya.
Dr. Pani? Sorry? Okay. So before you start, let me just give some brief point of your biography. So Dr. Pani is currently senior lecturer at the Faculty of Electric Engineering of University Technical Malaysia, Melaka. He is also energy manager at UTEC and is responsible for designing and running a professional practice of sustainable energy management in the university. So his research interests include energy efficiency, demand response, demand side management, distribution network reconfiguration, and optimization algorithm. He received his PhD from the University UITM. What is your UITM?
University Technology Mara.
Oh, University Technology Mara, sorry. In Malaysia, with focus on energy demand and energy demand side management. So in this occasion, he will deliver the topic of AI in energy demand side management. So your time is also with 50 minutes. So you have time until approximately 10:50, and the stage is yours now.
Okay, Alhamdulillah. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma warzuqni fahma. Special thanks to our moderator today, Mr. Fimansha, and also respect goes to our invited speaker as well, Prof. Afandi. So before this, I have seen kind of the video that has been uploaded in YouTube about kind of various area. The publications came from Prof. Afandi. Okay, so I also would like to thank Dr. Firdaus.
Assalamualaikum, Dr. Fani. Nice to meet you.
I got one message here from Prozaril. So he sent his regard to Dr. Firdaus and a fellow friend there.
Okay. Alhamdulillah.
So let's. So today I'm glad to share about this topic that within my area as well. So artificial intelligence for the demand side management. So this is my profile, a little bit about my profile. So I'm a senior lecturer from the Faculty of Electrical Engineering at University Technical Malaysia, Melaka. So one of the public university in Malaysia that are really focusing on these technical based education. So we have about 8 programs that focusing on the engineering and technology. Okay, UTEM started or established in 2000, the year of 2000, and until now we have produced about more than 20, I think about more than 25,000 graduated, especially for the bachelor in engineering. Okay, this slide show to us the contents for my presentation today. We have what is the demand side management or DSM, demand response program in Malaysia. So this is the introduction about this demand response program in Malaysia, bit introduction. So after that, we're gonna have AI in demand response or load management, and the final one is one of the success story that we have implemented DSM in our university as well. Okay, every day electricity energy is consumed by industry, by commercial buildings, and also has been used by the residential. And these conditions will lead to the spike of electricity use. Year to year, we can see a lot of, I think, about the generation expansions, or there is the planning for the new generation in the countries. Okay. And that's the various of load curve. For example, this commercial office building load profile. I think that the operations hours is May started 8 to 6 p.m., 8 a.m. to 6 p.m. And we have a peak demand on this daily operation as well, right? It's not about this operating hour only that the consumption of this electricity may contribute by or the variables may influence by the weather, the condition of the weather, and also the seasonings and the geography of the countries or place, and also the lifestyle. Okay, maybe the difference between lifestyle of poor people and the different to the rich people's lifestyle. Okay, people have money, have their own lifestyle, and they don't care about how much they can pay for the electricity cost, right? And how about poor? They struggle to put the electricity on their house, or even to pay for the electricity cost every month. And this load profile or the consumption of electricity may contribute by the condition of the holiday or the uncertainties like MCO during the COVID-19, right? That may lead to the closing of the building operations and the increment of the residential electricity consumptions. Okay, and also about the technology can influence the consumption of electricity. For example, if we have the electric vehicles, and this technology may contribute to the we would call it the patterns of the electricity demand in a building, in the residential area, or even for the industrial area. Okay, next, what we can see is demand increase and impact the generations that burn these fuel sources, right, and have given the tension to the generation when these load increase and the generation tensions. And of course, we can see in many countries, there is the price of the electricity increase, and the process of the generating the electricity has contributed to the impact to the environment or climate change. So the disaster I really interested when one of the journalists asked the Bill Gates about the issue of the COVID-19, and what will we get? Bill Gates said that the COVID-19 will be finished when we have the solution for it. For example, a vaccination or the herd immunity that we can achieve later on. But the most desired thing in the world right now that we have faced about more than 100 years ago is the climate change. So how to do how to solve this problem, or even to cut off the rapid changing of the environment today? So one of the solutions, one of the solution is demand side management, or DSM. So what is DSM? What is DSM? Could DSM, the scope of the DSM also including in the power system planning, the implementation wise, and the monitoring parts of the energy transfer. Okay, instead of we enlarging the electricity generations or we enforcing the transmission and distribution network, why not we encourage to modify the electricity usage or to mitigate the peak load demand, and by this way we can reduce the generation tension as well. So what's the other benefit of when we got to control the electricity demand? So everyone can have this benefit, started from the generation, the electricity provider, or even for the consumer. So consumer can reduce their electricity energy, and also for the financial saving. And for the provider, they're able to save these energy or the financial saving for the utility, and also for the CAPEX or PAC maintenance parts as well. And the most important thing is to sustainable the environment. But DSM has applied the strategic partnership with supply side and demand side. We can, in a demand side management, we can also consider the kind of the planning or the impact for the supply side as well. And the focusing, the main focus for the DSM, of course, goes to the demand side, which is to cater kind of the electricity consumption by the consumer. Okay, here in this slide, show to us the demand side strategy, DSM, that has been applied in the previous previous action under the DSM. So we have peak clipping on how we can reduce the peak demand here. Okay, that's the program, the strategy to reduce the peak demand. We call it as peak clipping. Okay, the second one is value filling, on how we can reduce, on how we can increase or utilize this value to be filled by the other loads. For example, we have 24-hour operations of the manufacturing, and how we can put the other load to the off-peak area, so that we can use the lower tariff over there. And the other one is load shifting. This one is very famous in the previous literature or in for the related research in demand side management or demand response. Load shifting, okay, on how the strategy to shift the load from the peak load to the lower or the valley area. The fourth one is flexible load shift. Flexible load shift describe on how these various parameter we can put on the to cater on the load shift. Okay, maybe we can align to the activity of the operations, activity of the lifestyle. Okay, to suit the price signal by the provider. And the other one is strategic growth. This one is for the planning. If we want to expand, okay, expand our operations, our building capacity to the other levels, so we can get a good strategic growth by applying this DSM strategy. And the last one is the conservation. It's the concept on how we can conserve this electricity consumption by changing the people behavior, by changing the system time hours consuming. That's kind of the examples for the conservation part. So as DSM support by SDG, Sustainable Development Goals, by UN, especially for the goal number 7, affordable and clean energy, responsible consumption and production, goal number 12, and goal number 13, of course, for the climate action. Ultimately, we can see that all those activity will support this SDG and try to contribute for the climate change. So what is the component under the DSM program? So sustainable energy must consider, first is energy conservation program. That this one is related to the behavior change awareness program, change of the duration, new habits. The most important thing here is the awareness program, how we can transfer knowledge to the people to really appreciate the environment, okay, to get aware about the environment, to protect the environment so that they can conserve the energy properly. So one of the example here, we can see to increase the levels of the temperature when we use this air conditioning system in our house, even in our office, and try to put them in the comfort level, but within the appropriate temperature, for example, to 26, 27, or 25. Okay, so when we use this computer, for example, try to put them in sleep mode when we are not using this computer, or even in our office, we can do some kind of the program, shut down before you leave, okay, before you leave the office. So please shut down your computer, or even during lunch hour. Okay, the another program is energy efficiency. This one we can refer to the technology solutions, the policy, the enforcement by the authority, the policy of the countries, the policy of the buildings policy, the technology solution, for example, LED lighting or inverter technology that we have applied in various kind of the appliance today. In our home appliance, or even in our office, or even for the industry. And also the VFD, variable frequency drive or speed drive for the motor, etc. Okay, this one is the technology solution, and also must be integrated to the policy, energy efficiency policy, for example, to get star rating for the appliance, 5-star, 4-star, and the saving percentage that this technology can contribute to the system. And the other parts is a demand response program that have been divided by two programs. They are incentive-based program. So incentive-based program actually kind of the program, the communication, the communication signal between provider and the consumer. For example, provider set certain requirement to the consumer to achieve, and then after that they can enjoy the discount. For example, to increase the load factor or to improve the load factor. Okay, the load factor. What was the equation for the load factor? Is the energy consumption divided by maximum demand or peak demand multiply with the daily hours, 24 hours, and multiply with a number of days in a month. So we can get the value for the load factor. So if this one of the examples in Malaysia, if the consumer able to improve the load factor, for example, and they can enjoy 20% discount. So what happened to the generation side when the consumer able to improve the load factor is that to tackle the load factor, to improve the load factor, we must what we call it, to reduce the peak demand. Okay, so when peak demand able to be reduced by the consumer, and that condition will influence the generation tension and to lower down the generation tension. Okay, that's why the energy provider will give or some sort of the offer or rebate or discount to the consumer that have subscribed this program to their electricity tariff. And the other side is price-based program. So price-based program is the pricing signal by the energy provider or the generations to the consumer in kind of the tariff initiative. For example, we have time of use, critical peak pricing, peak time rebate, short-term pricing. Okay, this one is a liberalized market like in most of the European countries, in the US, in the UK, or I don't have the idea. How about Indonesia? Okay, in Malaysia, we are the one of the country that still use what we call it regulated market, and not open market but regulated market to regulate these provider. But we have this kind of the time of use and enhanced time of use TOU to our consumer to get involved, and when they able to do some kind of the strategic program or even to apply this DSM, they can enjoy the reduction of the electricity costs. Okay, let us see the demand response program in Malaysia. We have, of course, for the price-based behavior or time rate-based program, we have time of use, TOU, and that's the improvement from the TOU to enhanced time of use, ETOU program or ETOU tariff that introduced in 2016. And previously, we have OPTR as well, off-peak tariff rider and Sunday tariff rider. That for the OPTR, so I did mention about the OPTR just now and the incentive-based program. Okay, so of course, there's the rebate about 20% for those consumer that are able to reduce or reduce the peak demand and increase the level of the load factor. And let's we see what is ETOU. Okay, so this is ETOU structure in Malaysia, the tariff that has been offered by Tenaga Malaysia, Tenaga Nasional Berhad. Previously, we have ETOU, that's the time zoning, the breakdown of the time of use tariff is peak and off-peak only. Okay, for this ETOU, there's the another area has been added, which is mid-peak area. So we have 6 time zone here. Okay, 1, 2, and 3. So with the difference of pricing for the off-peak, on-peak, and mid-peak, and also for the commercial industry, there's a 2 charge. One is the capacity charge, which is the maximum demand charge per kilowatt in power, and the other charge is the consumption charge, kilowatt hour. Okay, so there is the different pricing between off-peak, mid-peak, and peak area for the consumption charge, and also for the maximum demand charge kilowatt for the capacity charge, mid-peak and off-peak is different with the different kind of the price. So the offer of the ETOU with 6 time zones, 6 segments actually, 3 time zone, peak, off-peak, and mid-peak, and they also offer the peak off-peak price for the Saturday, Sunday, and public holiday. This one is the examples of the TOU zone per countries, and we can see here every country has their own idea on how to offer the consumer with kind of the different pricing. For example, India, they look for the industry here. They also have off-peak, a peak, and a mid-peak area with the different kind of the price. You know, the China have I think many more kind of the time zone design in China, but this one is one of the example of them. And for Brazil and also for Malaysia, we have ETOU to offer for the commercial and industry with the same kind of the zoning for the pricing. However, this is the challenge for the authority, especially for the Energy Commission in Malaysia. Less number join this ETOU tariff due to lack of the knowledge on how to manage their load. So people or a consumer think that this ETOU mechanism not suitable for the commercial and industrial load profile. Why this happens? Okay, why this happen? Not all consumers enjoy the OPTR or incentive-based program, or even for the price-based program like ETOU that has been introduced since 2016. And this is the opportunity for us in our lab, okay, to got something to help these consumer, like Al-Badi has divided. Okay, had got these. I got this. What kind of the info from the previous paper. So under the price-based program, Al-Badi has divided this price-based program to 4 major, and one of them is time of use. And in Malaysia, that is the 3. Okay, that's the 3 kind of work under the TOU tariff, which is to design this TOU design or to consider TOU for the provider and consumer. So for this previous research, they has applied the kind of the what we call it, the formula to consider both provider and consumer. But TOU for the consumer only, especially for the regulated market in Malaysia, we doesn't have a choice to do or to suggest, or we can improve kind of the tariff structure to suggest, but we can try to use this existing tariff to make something to help the consumer to get the idea on how they can deal with this existing TOU. So that here we have ETOU and the commercial industry. And previously in 2017, that's the researcher involved to help the consumer. For example, Prof. Mak Fauzi to introduce this ETOU industrial consumer in Malaysia on how this the effective way to help the consumer to enjoy this ETOU price, or even for the industry and commercial. But the opportunity here to improve of the load management strategy and to apply using this optimization algorithm method to get this strategy of the DSM strategy, for example, peak clipping, valley filling, and load shifting together in order to help the consumer to enjoy or to subscribe this ETOU program. So under the TOU load management strategy that consider consumer to get effort, okay, we have here the scope and the strategy like peak clipping, valley filling, and load shifting. And the idea is that to combine all these strategies simultaneously to put the what we call it, the formulation of that, and try to get the best load profile, the reference load profile, the optimal load profile by applying the optimization algorithm. Okay, the objectives to reduce the peak demand, and of course we can support the improvement of the load factor, and ultimately we can reduce the cost. And also here we can propose the other index for the load management sustainability as well. Okay, let us see the one of the examples of the implementations AI in demand side management for the ETOU tariff. In our lab, we introduced the PSO, actually the basic one as the PSO that has been established by Kennedy and Eberhard in 1997, inspiring by the bird flocking and fish schooling, okay, to find the food as well. So this kind of the particles that has been considered by PSO to find the P-best or T-best, or even for to capture on the optimum results within the short period. However, the problem with the conventional PSO is the less performed as the global numeric search, or even initial good potential always trapped as the fast movement of the search process. Okay, so that is the idea by Miranda in 2000, I think 2007, if I'm not mistaken, that has introduced EPSO, which is the hybridization of the PSO to the evolutionary programming. And this kind of the EPSO has been applied in various fields of the power system. For example, Jastrow in 2013, 2014 has applied this EPSO, even improved the EPSO in doing the solution for the distributed generation to reduce the losses when the integration of the DG to the power distribution that contributes to the efficiency of the distribution, power distribution, and reduce the losses. And also in our lab, we have applied this EPSO to reconfigure the distribution network system, okay, to find the minimum losses and to increase the voltage stability index. And by applying this concept of the combination, competition, and selection of the EP into the PSO algorithm, we have EPSO maintains only the strongest particle in the population, while eliminating the others, the weak one, but still consider the recall process. Thus, the strongest particle in the PSO allow the algorithm to achieve a faster convergence solution compared to the original PSO. Okay, of course, the concept of the PSO has been applied, for example, to find to set the particle numbers of n, position, to put the position, the velocity, and here, okay, and we put the calculation for the fitness of each particles and determine the p-best. Of course, in a PSO, we consider the p-best and g-best value and calculate the new position and the new velocity from the p-best and p-best. So here we can see here the new p-best and g-best can be updating by the new position. Okay, new position. The dotted black one can move to the other position as far away and close to the global best, or even the equation. Okay, we can see here the updating the position involve the old position and the new velocity, and the updating the velocity that involve the VI here is the old velocity, the initial one, plus the coefficient of the P best and the coefficient 2 for the G best. And however, this kind of thing can be improved and has been published by the Shi and Eberhard in 1998. They have introduced the weightage here, the initial part, okay, can be set between before that the old days they consider 1, but the initial part can be adjusted to maybe 0.9 or even lower 0.4, and we can find the best solution of the PSO output over there. Okay, what happened to the EP concept that has been engaged or hybrid in PSO to become EPSO, the tournament selections and the population sorted based on the higher score. The 10, for example, 10 positions are selected and the percentage is set to 40%, which means all the particles will be challenged by 4 particles, or 40% equal to 4 particles, right? You found 10 position. Okay, that's the kind of the tournament process selection. So when the tournament process like this, and we got the we got it here, the winning position. Okay, the winning and the score. WP stands for the winning particle. The score here, and we can select the high score to the sorting process, and you can find the best one in the tournament process to be the best value for the optimum one. So on how to deal, okay, with those simultaneous strategy of the demand side strategy right now, and to reflect the price signal on the ETOU, what we have done in our lab is to get this load profile from the power demand, okay, to get the load profile, to get the we can know the peak demands, the hourly consumption, the electricity price. Okay. Second one is to design. So what's kind of the formula we can use to represent the 6 segment of the tariff and the strategy that we can use. So here we propose the simultaneous strategy between peak clipping, valley filling, and load shifting. Previously, they have most previous researcher has applied this kind of the strategy separately, and within these 2 years, we have combined all those strategies, these 3 strategies, to be tested, and we want to see on the performance of this simultaneous strategy to reflect the tariff offered by the energy provider. And of course, for the constraint one, we have set constraint for the maximum demand to be in mid-peak zone, and the load factor, we have also set constraint for the load factor to improve. And this building economic index also, we need to improve in terms of the cost. Okay, the concept, we have tried to put a PSO, ACO, and a colony optimization and EPSO to be tested together, and we want to get the idea on what's kind of the performance that we can see between these 3 approach that we have in our simulation base. Okay, again, this is the flow on how the EPSO has been applied, and to check the convergence. Okay, and lastly, with the results to improve the electricity cost reductions, and of course to improve the load factor to cater on the maximum demand price as well. Okay, on this kind of research we have applied in this national level case study. For example, in Peninsular Malaysia, we got a 31 location of the electricity load profile by Energy Commission in Malaysia. So we have tried to put them in average and try to simulate to find the best load profile that reflect to the ETOU tariff. And also for the 11 location of the industrial, actually this one is the electronic manufacturing, because they are major manufacturing in the Peninsular Malaysia. We got the higher or the biggest manufacturing over there, about 11 location. And what happened here is we can see that after we put kind of the percentage for the load management for simultaneous demand side strategy that has been applied, you can see the last total electricity monthly cost has been reduced by using this ETOU. And we try to compare to the flat tariff and the TOU tariff with the different approach. And by using this algorithm, we can have the idea on the optimal load profile to suggest to the consumer. And when they mimic that kind of the load profile, they're able to reduce their electricity cost or monthly cost for the electricity. And here is the validation comparison. We can see that EPSO for the commercial building, C1 commercial building, by using EPSO with peak clipping, valley filling, VFLS is the load shifting, the simultaneous strategy within the minimum 30% of the load management, we able to get the saving for this strategy, okay, in at least stage of the 30% compared to the other kind of the approach, for example, PSO and ACO. And from there, the benefit of the EPSO algorithm bring benefit to increase the ability of the load management strategy in reducing the energy consumption cost under the ETOU tariff scheme. The simulation process will help consumer and energy service company to refer when dealing to the tariff selection. And for the future recommendation, the additional objective will be added, such as load factor and other policy index to be considered so that the efficacy of the integration load management strategy to the optimization algorithm has analyzed effectively. Okay, I would like to present the real implementation of the demand side management toward a smart and dynamic campus. So this happened to UTAM lately. We have energy consumption program, we have energy efficiency program, and also for the demand response program. This is our university located in the city of Malacca, the UNESCO heritage site of the historical in Malaysia, in Malacca. So please come and visit Malacca. Okay, the distance between Kuala Lumpur Airlines is about 130 km from the Kuala Lumpur to Malacca. So we one of the technical university network, MTUN, and one of the public university in Malaysia. So we have two campus, main campus and technology campus, established in the year of 2000, and pioneering in practice and applying oriented teaching and planning in methodology for the high technical education in Malaysia. So this is our strength for our human resource, industry engagement, student development, academic. We have many more programs and research niche area really focusing on the advanced manufacturing and computing technology. We have SEED Center of the Excellence for the research. And this one is the part, the view, sky view of the our main campus. A part of our main campus, we have net floor about 80,000. And we set of the baseline during 1 year in 2014 to June 2015. We have number of staff and students about 30,000, and we use these commercial rates, and we have subscribed the OPTR, one of the incentive-based program under the demand side management program in Malaysia. And we have set our planning for the strategic goals, 7 strategic goals, and one of them is number 6, okay, a smart and dynamic campus. So under the smart and dynamic campus, one of the strategy initiative, which is the strategy initiative 5, try to achieving the highest standard for the energy management cost standard by ASEAN Energy Management Scheme. So this one is the framework for the SAM, Sustainable Energy Management System. We started from year of 2015, which is the development phase, and we have moved to the phase 2 integration, and currently we are in the phase of sustainability, which is to achieve this year. We try to get the high standard for the energy management standard. And what happened in UTAM is the commitment from the top management, the continuity, the vice chancellor, the board of the director of the university that have given the commitment to support the demand side management program. So we got the activity, they joined the activity, and every single DSM report goes to the executive council that have been chaired by the vice chancellor. Okay, this is our commitment by top management to have this kind of the energy policy. So a continuous improvement to cover all the type of the energy commitment, to follow the regulation, follow the government green procurement, and also provide the resources. So to date, we have certified energy manager 33 person, registered electrical energy manager under the regulation of the electricity. We have 15% and certified professional measurement and verification We also have the Certified Energy Management Gold Standard Lead Assessor under the ASEAN Center for Energy, Committed Energy Auditor. Okay, we have integrated our procedure, all these things, even for the demand side management and our quality management, or even for the 7 strategic goal. And we have to sustain the awareness levels. Of course, we have the conservation program right now under the DSM. I did mention about how we can change the behavior of the people. So this one is another part that we measure, because we have 55 buildings in main campus, okay, and we have 20 PTJs, which is the locality that we have divided them to 20 locality that has been led by assistant energy manager for each building or PTJ. So what's kind of the program they have put to the effort to increase the level of the to understand the policy, the motivation to enhance the awareness program, the reporting, the innovation, and etc. Okay, these are the examples of the energy conservation program. All right. So the other thing is to put the IoT monitoring system. We have close monitor the consumption of the electricity for each of the building under the main campus, UTAM main campus. So as you can see here, for example, the left side, okay, the profile of the one building, we monitor the program of the shutdown before you leave in lunch hour. So we got the result from there. We can monitor closely the action of our staff or even our student as well. So we can compare to the provider bill, the consumption one, the maximum demand, and we also prepare the billing for each buildings, and to continuous monitoring all of the buildings under the main campus. Okay, this one is the smart building management. We have spent about 3.4 million to enhance our building management system to optimum cooling system operation. And we have detailed up all those buildings under the main campus to involve in a smart building management system, and every single cooling parameter we have put on the centralized system like this. And also, in order to reflect to the price signal by the energy provider, I did mention about the OPTR just now, right? So we have subscribed the OPTR under the incentive-based program for the DSM. So we have put the effort to get the simulation output, and we have used the optimization algorithm to prepare this simulation. For example, here, okay, this one is simulation based. Okay, from this reference, the reference look profile that we have. Okay, the blue one is the baseline, and the orange or red one, the red line here is the suggestion from the algorithm, the simulation. So we try to mimic this process and compare to apply in the real building in our university. Okay, so what we have done here is to tackle on the cooling system, because the contribution of the energy consumption from the cooling system is about 70% in our building. So what we have done, we try to manage our cooling system by using building management system, put the effort to engage with this simulator. So what happened to this building, we able to increase the load factor, and by this requirement, we have fulfilled the requirement from the Energy Commission or even from the provider, TNB here, and we can save about 10% for each building. So to date, we have recognized by this international award, etc., and we have put the IP for this kind of method that we have in our university. Okay, this one is the process.
Dr. Pandey, I'm sorry, just
Yeah.
to remind you that we have 5 minutes remaining.
Oh, okay.
Okay. Just for a friendly reminder.
All right, thank you. Okay, so today we have achieved about 9 million reduction of the electricity cost, and has contributed to reduce the CO2 emission for about 40,000 ton. Okay, this is the index. We have improved the index for the energy, and electricity consumption cost per capita have been reduced lately. And this one is the tabulated energy saving measures by that's been contributed by all the measures taken under the DSM. And ultimately, we have been awarded by National Energy Award and ASEAN Energy Award this year for this all the effort of the DSM that combine those strategy together. And this is the research lab focusing on the DSM in UTAM. We have capacity building on that, and this is my offer to those who are interested to join our energy and power system research lab for the PhD candidate master. This is the first DSM research lab in Malaysia to help the regulator, to help the provider to combine the demand response effort and energy efficiency program. Okay, so the end of I think that's all from me. The end of our presentations. Okay, thank you.
Okay, thank you very much, Dr. Pani, for interesting and very precise presentation about the DSM. Okay, time is running, so I will now open the discussion session. Let me open the list of questions. Okay, while I'm opening the list of the question, any one of you who wants to ask directly can raise your hand and ask directly to the both of our speaker. Okay, we have some questions here. The first question is for Professor Afandi. Can thunderstorm algorithm be applied for the unit commitment problem? Okay, go ahead, Professor Afandi. So the question is, can the thunderstorm algorithm be applied for the unit commitment problem?
Yeah, okay. Thank you, the moderator. It's good question for me. Thank you very much for the questioner. Yeah, I think the thunderstorm is one of the computational methods, so it can be applied in many cases, not only in unit commitment, but also other optimization problem. Because the thunderstorm algorithm is a computational method or approach, so you can apply if you know and you understand about the problem and how to solve and how to apply the thunderstorm algorithm to getting out the your problem or another problem, not only in unit commitment. Thank you.
Okay, thank you very much. Second question is for Dr. Fani. What is the effect of electric vehicle penetration for the DSM?
Okay,
go ahead. Yes.
Thank you. That's a good question. electric vehicle currently has been applied in many countries, has been launched since last 2 decades. I think that the impact of the electric vehicles to lower down the peak demand, the peak demands in for the consumer side or demand side is really important. So that's the kind of the parameter to be considered, especially on the I think on the consumer side, they need to have kind of the we see kind of the smart monitoring, okay, to have this idea on how this EV can influence or the patterns of the usage of the demand side management. Okay, so for the AI that has been implemented to integrate this EV for the demand side management, the impact is on how we can manage the charging stations, the locations of the charging station in distributed in this power distribution system. That one is important to maintain the stability of the distribution network. Okay, so where the optimal place to put the charging station is important, and for the household use of the EV plug-in station, that one is to consider. Okay, to consider EV to reduce the to valley the to fill the valley. Okay, we have a strategy of peak clipping and a valley filling. So one of the strategy for the valley filling to put the EV, the charging part during the valley period or in off-peak period. So the opportunity to apply this artificial intelligence, for example, many more algorithms that we have in the market today, is to find the correct location to put these kind of the charging station for the EV, and even to get the right sizing for the EV charge or even for the EV battery. I think that's my idea to reply on this question.
Okay, so just let me add some point. When we are talking about the EV, so the unique point of EV is that it can be considered as load and as a source as well, because it charge and discharge as well.
Bidirectional.
Yes, yes. So it will slightly complicate the problem, but it has many benefits. I think. Is it like that?
Yeah.
Yeah. Okay. It will be a good idea for research, I think. Okay. The next question is. Okay. For Dr. Fani again. What is the impact of distributed generation for the GSM? So a similar question, but he's now asking about the DG instead of electric vehicle.
Okay. Thank you for the questions. DSM, the integration of the DSM in the power system, close to the generation, the transmission, and the distribution. Okay, so when we talking about DSM is correlate to on how the behavior, the technology we use for the consumer, and the price signal from the provider, and the impact, the positive impact also goes to the distribution network. Okay, so when disengagement to reduce the enforcement for the distribution network, the CAPEX or the OPEX operation or maintenance costs will be reduced as well. So that by this way, the cost, like Prof. Effendi said just now, the cost for every single transmission, distribution, they have a certain costs to maintain and has been embedded in the consumer tariff. So that by this way, when the performance of the demand side management is in the climate effective way, and they can what we call it, contribute to lower down the price of the maintenance for the distribution as well. That in the economic aspect. And the other thing is when this, I think the engagement, okay, about the price signal, and also in distribution network, they have the other part is to like I did mention about the load factor, okay, the load factor, and when this peak demand has been reduced, and the tension of the generation, transmission, and the distribution network will be lower down. That's the idea on the contribution from the DSM to the distribution network. But when we need to look at on the type of the distribution network as well. Okay, the radial one, the mesh one, the variety of types of the distribution network, we will play the good sign of the positive impact from the DSM. For example, on the reconfiguration network, reconfigure when the blackout happen, on how a peer-to-peer program, and how this fast convergent optimization algorithm can help DSM and the distribution network to work together to solve the blackout area, okay, to minimum the losses as well. I think that's the idea for this question.
Okay, thank you very much. Now I invite the participant to ask directly. Please raise your hand. You may ask in Bahasa, not necessarily in English. You can ask in Bahasa also. Okay, anyone?
Ramai, kita ada 100 orang ni.
100 orang, ya. Silakan kalau ada yang mau bertanya dengan bahasa Indonesia.
Saya dulu Pak Sabar Dawan dari Universitas Mataram.
Silakan Pak. Pak Sabar, silakan.
Pada Pak Fani, tadi sudah saya tuliskan tadi sebenarnya itu bukan hanya distributed network, tapi distributed generation misalnya. Memang integrating of micro hydropower system to the distribution radial distribution network. Itu Pak.
Okay, about DG lah.
Ya,
DG.
tadi pertanyaannya DG ya.
DG ya, bukan distributed.
The previous question
generation
is about DG, not the distribution network.
Bagaimana pengaruh distributed generation kepada DSM?
Okay. Okay, DSM is the first level of the solution for the climate change. This is my idea. Energy efficiency, energy conservation, demand response. Macam di UTM, apa yang kami buat, energy efficiency come first. Okay, we reduce the energy consumption, And after that, we go to another level, which is to integrate the distributed generation like PV and these other distributed generation types. For example, tadilah yang Pak bagi tahu. Okay, so dia impact dia kadang banyak tempat, banyak bangunan mereka terus pergi kepada DG solution, PV and another type of the DG. Tapi behavior change on the consumer, kita kena fikirkan dulu macam mana nak ubah behavior to put the awareness program first. Okay, so we can change the mind of the people first to get this another level, so they can appreciate the other technology put on the system. For example, distributed generation. Itu bila DG masuk dalam distributed generation, impact dia kepada DSM itu lebih menarik dan lebih memberi kesan kepada owner building or even for the energy provider. Boleh dapat ke?
Jadi price, bagaimana mengenai tarifnya? Apakah kita cukup menggunakan KWH meter itu, Pak? Tarif misalnya ada PV di universitas, terus kita kan sudah mengeluarkan banyak investasi untuk PV, integrasi dengan radial distribution network. Bagaimana tarifnya? Apakah kita cukup menggunakan KWH, Pak?
Okay.
Klarifikasi.
Dia tarif ini bergantung kepada negara. Di Malaysia, kita dalam regulated market, kita ada monopoly system dia panggil. Satu provider sahaja yang provide electricity. And government akan jaga provider ni. Okay, so kalau kita ada DG dalam university, for example, we can enjoy the reduction of the tariff and also we can supply or sell this lebihan daripada penggunaan kita kepada provider. So we have fit-in tariff, kind of the fit-in tariff as well in our pricing system. Itu yang berlaku lah. Tapi kalau nak tengok perancangan, saya boleh share perancangan Malaysia macam mana kita nak integratekan PV dalam power system kita. Boleh saya share ke?
Silakan.
Okay. Ini another proposal structure yang di Malaysia sekarang ni. We have IPP, TMB generation, so that we have single buyer operation. That this one is the liberalized to cater on the bidding system in order to supply this electricity. So that's the liberalized market on the generation right now. And then Gentailer here is the like solar farm, like the biggest DG that we have in our system. So they also made to contribute or supply this electricity to the transmission. And on the distribution or even in the consumer side, we have TMB retail as the main provider, and also we have alternative retailers here. And then Gentailers is kind of the DG place. For example, the consumer that have PV in their house can sell also their electricity to their neighborhood, okay, by using the P2P program. So how this P2P can communicate? Nowadays, people talking about this blockchain technology. So try to get the idea on how this blockchain technology can influence our what we call it, the electricity market as well. So di sini kalau Pak perhatikan adanya generation, transmission ada price dia, distribution ada price dia, and we come up with the consumer price. At the end of the day, consumer will get their average price. So Gentailer here can sell also to the consumer, and consumer that have PV or even though the DG integrate in their building or even their house can sell this electricity to their next neighbor or their locality as well.
Oke Pak, terima kasih.
All right.
Okay, thank you very much, Dr. Fani. And I think due to the time limitation, we have one last question now. The question is for Professor Afandi. The question is about the